I'm going to go over some strategies and tactics for doing proofs, particularly now that we have a completed the first order logic language that we're working with. So here I'm assuming that we have a first order logic with conjunction, disjunction, negation, the conditional, as well as the biconditional, and then the two quantifiers, the universal quantifier and the existential quantifier. The first thing that you should always do is know just what the sentences mean. If you don't know what they mean, it'll be difficult to identify or be able to even know which of the questions below that you need to be able to answer. So if you don't know that a sentence is an existential quantifier as opposed to a conjunction, for example, you won't know whether to answer yes or no to the question, is there a premise with a conjunction, or is there a premise with an existential quantifier? Related to understanding what the sentences mean, you want to make sure that you think about an informal proof. If you can work through an informal proof and convince yourself why an argument is valid, that informal proof, the steps that you take, will be able to inform you how to do the formal proof. The way that we've designed the Fitch proof format really closely resembles how we actually do the informal proofs. This is in fact why the system that we've been working with is often called a natural deduction system. Okay, so after you've done this type of informal work where you understand what the sentences mean, and you're also you've got some idea of how the informal proof will look like, then you can start doing a formal proof in our system, Fitch. And so what I've done is collect some questions that you should ask yourself as you're working through the formal proof below. I've put this document up on the Blackboard Learn website as well. So what I'm noting as well is that when I use italics in the answers, that is what we call a forward-looking strategy that takes either premises that you already have or steps that you've derived and moves forward, right? So you're moving from the top down. In boldface are the answers that are backwards looking. So these strategies start with the goal or maybe some sub-goal that you've gotten to and thinks about what do you need above that step in order to be able to get to it. So those are sort of backward looking strategies. An important note for any of these strategies to work is that you already need to know how the basic version of the rule of inference works. If you don't know, for example, that existential elimination requires a subproof, you need to go back and review how that rule works first. Okay, so here are the questions. The first handful of them you should remember from previous lectures that we've done. So this is asking, is there a premise with a conjunction? Well, then you can do conjunction elimination. Is there a goal with a conjunction? If yes, then do conjunction introduction. Is there a premise with a disjunction? Then you need to do proof by cases, which in Fitch we called disjunction elimination. And I've just noted here that this actually requires subproofs, right? One subproof for each disjunct. And your goal in each subproof is, or your subgoal in each subproof is going to be the same goal in each single subproof, which is the goal that you want to be able to state on the main line. Is there a goal with negation? If yes, then do a proof by contradiction. Again, note that that requires a subproof. Is there a goal that is a contradiction? Then, if yes, then look for a contradiction, and there's two ways of doing it. You can either deconstruct previous sentences, so you'll notice that certain parts of the sentences, like certain parts of a conjunction, if you can take those out, would give you a contradiction. Or sometimes we build contradictions using introduction rules, right? Using either conjunction introduction or perhaps conditional introduction. You can sometimes build sentences up that then will contradict each other. Don't forget, of course, about disjunction introduction. If you've got a claim, you can always add a disjunction with an additional claim. Did one of the steps yield a contradiction? So sometimes the goal isn't actually to get a contradiction, but something else. But you'll notice that along the way, there is something contradictory about a given set of assumptions that you have, and perhaps an additional assumption that's at the beginning of a subproof. Remember, if you ever get a contradiction, anything follows from that, whatever you want. So you can use contradiction elimination there to be able to make that statement. Okay, is there a premise with a conditional? Then remember, you can do modus ponens, or what we called conditional elimination, as long as you also have the antecedent of the conditional. Is there a goal with the conditional? Then you should do conditional introduction, and that again requires a subproof. Okay, so here's the 4 questions you should ask once we have quantifiers. So it's important to remember these other questions above-hand before you start getting to the quantifier questions. Is there a goal with a universal quantifier? Then you should do universal introduction, and remember that that actually requires a subproof. Is there a premise with an existential quantifier? If yes, then you should do existential elimination. And remember, that also requires a subproof. Is there a premise with a universal quantifier? If yes, then you should do universal elimination. Now, here's an important note about this. Although universal elimination doesn't require subproof, you'll often need to do this universal elimination inside the scope of a subproof that you've already started by doing something like existential elimination or universal introduction. So I have ordered these questions specifically. Don't skip ahead to one of these other questions without having asked one of these other questions first and using the proof strategy that corresponds with it. Final question then is there a goal with an existential quantifier? If yes, then do existential introduction. Here again, right, this rule of inference does not itself require a subproof, but it often will get used inside the scope of a subproof, as you saw with some of the examples using existential elimination. So again, don't skip to doing this strategy if you haven't already asked the question and used the strategies above as appropriate. So I'm going to walk through this document going over some examples for proofs so that you can see how these questions and strategies apply to more complicated cases.